Hello, Professor. I am presenting my programs, my 6 programs for Lab 3 on video. And here I will be showcasing the results and explaining the results of each program given Lab 3. Starting off with polynomial regression. Here we have our equation, and it will be plotted here, and this is what will do the polynomial regression curve fitting, and it's right on top of the original plot, so that works out. Here we have the linear regression. We use the same equation as the previous one, but instead of polynomial regression we use a linear fit as curve fitting. So if we clear this, we should have a line going through the polynomial, and that's exactly what happens. Now on to the damped sine wave. This is essentially creating a damped sine wave. Damping being it eventually stops oscillating and reaches equilibrium. And this is essentially the equation, and these are the values I set it to. This is how it's plotted, and this is how it's curve fitted. So if I run that, you get this result. It may not be right on top, but it's close enough. It essentially still predicts accurately. Now onto the sine wave with noise. Here we had our .csv file, and we use that .csv file to output our sine wave. Then we add noise to it using this code block and curve fit that noisy sine wave through this curve block. So if we run this, we're going to get this. So we have our sample sine wave with noise, and sample sine wave with a curve fit. Onto the multi-variables. This one uses 2 variables to create a R graph, and depending on the hints, depending on the values of the pair of variables we input, it's going to be far or as close to the original graph as possible. So here it's right here's the hints, actually right here. So these are the hints. If we run this, we have our results here. This is the graph that we created using this part. This graph prediction is right on top because it was guessed properly, or as close to the original as possible. May not be right on top because you still see some of the blue, but it is close enough to say that it's an accurate prediction. And then we have the hints here. As you can see, this would be the 0, 0. This would be the 0, 10. This would be the 100, 100, the 6, 8, and the 3.14 to 10. So that's the multivariable. Now I'm gonna go into the coin, which I changed, but instead of the actor being the fox and the coin, we now have the snake and the hedgehog. And instead of the fox collecting coins, it's now the snake eating the hedgehogs. As you can see here, whenever snake collides with hedgehog eaten, I instead of 10 points, it's 1 hedgehog eaten, or 1 score. I also added a timer, And I made that timer 30 seconds. To accommodate for the new game, I changed the background from a lighthearted background into a horror story kind of background where the background is black and the text messages are red. I also increased the size of the background just to make it bigger. And if I run this code, you're gonna see a completely different game from before with a timer. Oh, one more thing. I also increased the speed of the actor, in this case the snake, from ±2 to ±10. So it's 5 times faster than before. So if we run this code, this is what we're greeted with. So as you can see, there's a timer. Let me run it again. That is weird. It moved on its own. So as you can see, there's a timer on the top right and the score on the top left. And the snake is 5 times faster than the fox in the original code. So this is my 6 programs for Lab 3. Thank you for watching.